Okay, so we're going to try to solve this first mass problem together, and then I'm going to let you go. So we're going to start with this equation right here. And always, as always, we annotate. So the first thing we do is we look at this equation, underline it. Is it balanced? Well, let's check it out. 2 n's, that's 2. 2 n's, that's 2 over here. That looks good. F's, 5 times 2 is 10. 10 F's on this side. I have 4 F's here. 6 times F is 6, plus 4 is 10, so I have 10 F's on both sides. Awesome, it's balanced. The next thing, let's read the problem. If you begin with 45.7 grams, 45.7 grams, boom, underline it, draw an arrow, say, this is what I need to calculate. Put an exclamation point, great. Of ammonia, NH3, how many grams of dinitrogen tetrafluoride, or N2F4, are produced? Okay, so we know we're starting with this right here, correct? Oops, excuse me. So let's try that. Grams, or just G, of NH3. And what do I want? Well, I want to get to how many grams of dinitrogen tetrafluoride. Looking at our house of stoichiometry, oops, where's my house of stoichiometry? There it is. Looking at my house of stoichiometry, this tells me when I have the grams of something given, I need to slide down the molar mass slide and find out the moles of the given before I can calculate the moles of the answer and the mole of the given in the coefficient hallway, so that I can get moles of the answer, go up the molar mass steps to the grams of the answer. Because remember, it gives us the grams of the given, which is NH3, and it wants us to find the grams of the answer, which is N2F4. So I have to go down the slide, across the hallway, and up the stairs. Let's try it out. So I need to go down the slide, which is going to require me to find out the moles of NH3. So I know that when I'm calculating the molar mass, I need to look at my periodic table and find out how much 1 mole of each of these elements weigh. So I look at nitrogen on my periodic table, and I find out that nitrogen weighs 14 grams. 1-4. Check it out on your periodic table. See if I'm right. Nice, I am right. So let's check out the next thing. That's 14 plus H3. So I have 3 H's, and when I look on my periodic table for H, I find out H weighs 1 gram for every mole. So great, there's 3 of those. 3 times 1 is 3. 3 plus 14 equals 17. So I know that I'm going to have, excuse me, so I know that I'm going to have how many? Well, I want 1 mole of NH3, and I'm trying to get rid of grams. So how many grams do we say? 17. 17 grams of NH3. Perfect. So when that happens, grams of NH3 cancel out. Cancel out here. Cancel out there. Oh, and the grams. Great. Now, oh, excuse me, the 17 shouldn't be canceled out. So the 17 is not part, there's no 17 of here to cancel out. So I just cancel out the units here, the units here, and I get my answer is equivalent to let's see, 45.75 divided by 17. I can do that math. 2.69. When I do 45.75 divided by 17 equals 2.69. Perfect. 2.69, or just 2.7 moles of NH3. So when I do that, now I know the moles of NH3. But am I done? Not quite. So let's check it out. The next step, when I look at my house of stoichiometry, it tells me that I need to find out now, I need to go down the coefficient hallway right here. Find the moles of the answer over the moles of the given. So let's do that. So I have this many moles of the given, and I need X. I need to find moles of the answer. So I'm going to put moles of the answer on top, and I need to look at my recipe for that. Here's my recipe. So what is the answer? N2F4. How many moles do I have in my recipe? 1, because there's nothing there. So for every 2 plates of NH3, every 2 plates, I'm going to make 1 plate of N2F4. So I'm going to put that down. 1 mole of N2F4. And that is going to be over, oops, excuse me, two moles of NH3. So now, when I write that down, I realize that the moles of NH3 cancel out because they're right here and right there. Boom. So what am I left with? I'm left with 2.7 times 1 mole of N2F4 over 2. And that answer is equal to 2.7 divided by 2. So let's do the math. 2.7 divided by 2 equals 1.35. moles of N2F4. Great. I'm almost done. Now, for the last part of the house of stoichiometry. Let's check it out. It says to take the moles of the answer and go up the molar mass steps. Put the grams over 1 mole to find the grams of the answer. So let's do it. Here we go. So we have the moles of the answer, and we need to find grams of the answer. So first we have to find the molar mass of the answer. I have 2 n's here. How much did we say n's were? 14, right? 1, 4. So 14 times 2 is 28. Great. Now we have 28. Now I want you to look up F on your own right now in the periodic table and write down the answer. How many grams are in every 1 mole of F? Give it a second. Okay, you'll see the answer is about 19, 18.9 something. So it should be 19, and 19 times 4 is a little less than 80. It's about 76. So 76 plus 28 is how much? Let's find out. 76 plus 28 equals 104. Great. 104 grams of N2F4 over, you know the answer. We've done it so many times now, I know you know it. For every 1, oops, excuse me, let me make that bigger. For every 1 mole of N2F4. There it is. So, check it out. Moles of N2F4 cancel out. And what are we left with? Grams of N2F4. We have 1.35 times 104. Let's do the math. $140.4. Let's just go with 140. Equals 140 grams of N2F4. And boom, there is our answer. So I know you guys can do this on your own. Give it a shot. Boom.